I'm Fred Pinkney, an aquatic toxicologist with the U.S. Fish and Wildlife Service Chesapeake Bay Field Office in Annapolis, Maryland. My presentation is on the survival and growth of juvenile Lampsilis radiata, that's the eastern lamp mussel, deployed in the tidal Anacostia River Watershed, and I want to thank all my collaborators and co-workers. The overall goal of this project is to evaluate the suitability of the Anacostia River for enhancement of freshwater mussel populations. There are 8 species in small numbers right now. This work is part of a combined effort between the DC Department of Energy and Environment and the Anacostia Watershed Society. Here our objectives were to compare the survival and growth of juvenile Lampsilis radiata at various locations in the Anacostia River watershed. We also are evaluating the quality and quantity of ceston, roughly speaking, mussel food consisting of suspended particles between 0.7 and 100 microns. And finally, to investigate relationships between ceston and mussel growth. The project started in October 2017 when co-author Dr. Rachel Mair and Harrison Lake National Fish Hatchery staff collected gravid females from Bryan Point on the Potomac River, the reference location for this project. They were infested into largemouth bass, and the juvenile mussels were maintained in tanks for about 8 months. On June 19, 2018, co-author Luis Chevez picked up about 1,700 juvenile mussels for next-day deployment in the Anacostia River and Potomac River watershed. We took photos of every replicate so we would have week 0 length and height. And here we show how you determine length of a mussel, height, and width, which we can't do on the photographs. The inset map shows the United States with the heart for Washington, D.C. and the D.C. flag. If you look at the Anacostia River, it's up at the left side of the image, starting at Buzzard Point near its mouth in the Potomac and going up about 8 miles of tidal river. Then the confluence is with the major tributaries northwest and northeast branches, and then further up I show Beaver Dam Creek, which is in a forested watershed up near the top of the Anacostia River watershed. On the bottom is Bryan Point, where the gravid females were obtained. The study design was a 9-week deployment starting in June 2018. There are 4 silos per site, 20 mussels per silo at silo locations which were where currents were strong. In protected areas, we had baskets, and in our study design, we had 8 baskets per site with 10 mussels per basket. This slide shows the mussel silos with the initial loading of 20 juvenile lamp mussels on the left. On the right, it shows what happens when there's siltation. You can see this silo almost completely filled with sand, and the arrows point to the juvenile mussels. So we were watching these weekly to make sure that the integrity was good. We also, in this slide, show the floating baskets. These are 13-liter plastic baskets sold as colanders by Johnny's Seeds. We line them with fiberglass window screen on the sides and top, and 200 micron nylon mesh on the bottom, which held about 5 centimeters of play sand as substrate. Then we wrap them with pool noodles as floats, and protected them either with PVC in a bigger float for the capital stand-up site, or we used enclosures for the marsh sites. So there was weekly monitoring for siltation and loss of sand. On weeks 3, 6, and 9, we obtained ceston samples by sampling water and processing it in the laboratory with Roger Thomas, co-author, as the lead at the Academy of Natural Sciences of Drexel University. At week 0 and at the end at week 9, we measured length and height using ImageJ software. The samples were processed to measure ceston quantity, consisting of the amount of particulate matter and the amount of particulate organic matter. We determined ceston quality by measuring the amount of protein, carbohydrate, lipid, ash, chlorophyll A, and phaeophytin in the ceston. Buzzard Point, shown here on the left, is the silo site near the mouth of the Anacostia. You can see a pretty big fetch here and some current. This is not suitable for baskets. We use Kenilworth Marsh as a basket site, and that was well protected. You can see it looks like a pond. This shows the measurements we took with ImageJ. On the left, you can see approximately 9 millimeter long mussels at the starting point, and at week 9, these mussels range from about 23 to 30 millimeters, so quite a transformation over the course of 9 weeks in the summer. For data analysis, we analyzed the silo and basket sites completely separately. Our main endpoint was survival. The sublethal endpoint was growth, and that was measured as the average increment in either length or height per replicate. So it's basically the difference between the average at week 9 minus the average at week 0. We use MANOVA, multivariate analysis of variance, to look for differences between locations. The covariate here was the week 0 measurements because there were slight differences. And finally, we use Spearman rank correlation to analyze or look for associations between growth and the measures of ceston quality and quantity. Survival was over 90% in all locations except the silos at 11th Street. That was 79%. That was statistically decreased or significantly decreased from the other silo sites, and the 11th Street site was not carried into the growth or sublethal analysis. This map shows the location of the confluence, and that site was lost entirely because of heavy storm flow. And then it shows the 11th Street where we had the decreased survival. The silo sites, we had essentially 0 growth in Beaver Dam Creek. That was statistical group A. Group B was Buzzard Point, 19.4 average length increment, and Bryan Point, the reference site, 22.7. Looking at chlorophyll A is near 0 at Beaver Dam Creek, both locations, and that is shown in the chart on the left here, where chlorophyll A goes from 0 to 20, and it's very close to 0 in measures weeks 3, 6, and 9, all 3 water sampling periods. You see the highest chlorophyll A in Bryan Point on all 3 occasions, and that was the location that had the largest growth. You see that on the right where we're looking at change in length on the y-axis and chlorophyll A. So the extremes are Beaver Dam 0 and 0, 0 chlorophyll, 0 growth. And then Buzzard Point, about 5 micrograms per liter chlorophyll, about 20 millimeters growth, and Bryan Point, about 23 millimeters growth, and 10 to 15 micrograms per liter of chlorophyll A. We also note that Beaver Dam Creek is much greater canopy, 2 degrees lower, probably doesn't have very much algae to get these pigments. The basket sites, we have 3 statistical groups. The highest is at Kenilworth Marsh and Heritage Marsh, both the protected areas. Capital Stand up a little bit lower, that's in the main river, but somewhat protected by a dock. And the lowest was Kenilworth Aquatic Gardens, which may have poorer water quality, did have very high temperatures at some periods, so that could be due to ammonia or sulfide perhaps. And here looking at the chlorophyll A versus growth, again, if you just skip ahead to the right, you'll see the lowest chlorophyll A and the lowest growth at Kenilworth Aquatic Gardens and much higher elsewhere. So we conclude that the results support the use of hatchery-bred Lampsilis radiata for enhancing populations in Anacostia and perhaps other rivers. We recommend in Anacostia placing juveniles in baskets in protected areas for 3 to 6 months, and we report that chlorophyll A and phaeophytin were positively correlated with growth. We thank the DC Department of Energy and Environment for funding, and the Anacostia Watershed Society for help in the field, and Dr. Elgin Perry for statistics. Thank you.